Well, good evening. Uh, been very busy, been away from the channel for some time, but there's a short period of calm between a big conference that we have next week and a trip that I've got to do and what I've been going on to. So I wanted to come back and see if I could finish up the um, logic analysis. If you remember from the last video, where we left it was that I was pretty certain that one of two things has happened. Either these little CCFL bulbs had blown, or the inverter had blown. Now, typically, I've seen these bulbs wear out and get dimmer and eventually not work. But most of the time, the failure is in the board here. So, optimistically, what I did is I bought a couple of boards. Thinking, well, I bought one, and then I got it and I tried it and it didn't work, and so I bought another, and I tried it and it didn't work. And so at that point, I was left sort of considering, well, what is the actual issue? And so if we have a look here, you can see this is the actual, let me see if I can get that light out of the road. This is the actual original board that was in the unit, and this is a TDK CXA 0384. And this one here is also a CXA 0384. I'm pretty sure, because I took this one out of the actual unit, that this is a real device. And I'm pretty sure that this one and this one here are clones. Now, the interesting thing about this board here is you'll see that TDK Lambda built it as a dual-use board. So the power output, or the inverter components here, are duplicated on both sides. And so you can have a 2-bulb version, which is what we have here. If you look in there, you'll see that there are 2 bulbs. So we have a 2-bulb version, and then we have a 4-bulb version. And it basically just duplicates the componentry on either side. Now, the problem that I was having with it is that they weren't working. And so in a system like this, you have 3 components. 1, you have the power supply that's coming into it. 2, you have the inverter, and 3, you have the bulbs. So without having, I had to get replacements for both, because I can measure the power coming in, but because of the way these are set up, you can see all the rubber sealant, the silicon sealant in here, to protect you from touching the high voltage. It's very hard to measure whether the unit here is actually outputting any high voltage, unless you get a pigtail lead and you plugged it in there and so on. But I didn't have one of those. So what I did is I bought another set of bulbs, and when I got my first board and I tried it, it didn't work. I bought a second board that came out, and this one clearly is not the exact same board. You can see it is supposedly TDK Land, but it's a later unit. But they did go through a period of time where they moved from the 0384 to, I think, a 534 or 535. And so this might be the board that TDK sort of recommended as the thing there. Again, I don't know if this is a real board or a clone or what. Anyway, I got these boards, I got the bulbs, still didn't work. I checked the values on the voltages, still didn't work. And then my parents came to town for my birthday. And so we spent a week together, and my dad, I took my mum out to go do something, actually go spend some time with my wife. She's a school teacher in her class. And so Dad stayed at home and poked around on the board a little bit, and what he discovered was that this little thing here, let me see if I can zoom in enough so that we can actually we'll see if it actually resolves, because sometimes the shiny light is a little hard. But you'll see, let me get where's my little pointy stick? What he discovered was this component here was open. Now, if you look at the connector here, what we have here, and this is the clone board, I think. What we have here is we have 12 volt, 12 volt, and then we have ground, and then some control voltages going up off the top there, to turn, to do dimming and to turn the unit on and off and that. But basically, the two 12-volt lines go through this component here and then into the rest of the unit. And so Dad checked that component, discovered that it was, it was an open circuit. And so it clearly was not going to get any voltage through into the thing here. Now, the 20 on it mislead me, and you guys are probably all going to be, be saying, oh, it's clear, it's obvious. I looked at it, and I swear, I thought it was a resistor. And I said, no, that's a resistor. So I got to go find a 20 ohm resistor. I didn't have any 20 ohm surface mount resistors, but I had some, other resistors. And so, I took them, and you can sort of see the legs here, and, I put those across that to make it. And lo and behold, bam, up it came and it started working. Now, what was happening though was that those resistors were dissipating about, they were dropping about 5 volts across the resistor and dissipating a lot of power, up to 2 watts there. And so that was clearly, I went looking for a resistor that was a high wattage. I thought, well, maybe it's the ground plane sucking the heat away and so on. And then I asked on the EV blog, and people said, well, maybe it's a ferrite bead, or maybe it's an inductor. And then as soon as they said the inductor, the light went off, and it was like, oh, of course it's an inductor. Because right next to it, what you've got is a capacitor, and that capacitor connects to ground. That plane there is ground. And so it forms a little LC filter, and that's filtering, it's a low-pass filter, so it's filtering high-frequency noise that comes in. And I bet dollars to donuts that is probably there to filter high-frequency noise coming back up the regulated 12-volt line and going into the rest of the system, coming from the inverter. And so as soon as they said that, I'm like, oh, of course it is. So I went out and I bought the closest I could, some little 2.2 amp, let me get that in shot, some little 2.2 amp, 20 nanohenry inductors. They don't make an inductor, as far as I could tell, in this size anymore. So what I'm going to go do is I'm not going to use this one here. I'm actually going to go and, let me zoom back out here. I'm going to go and take the inductor off this guy here and then replace it with the inductor there. So let's go turn on my soldering iron, because I don't think I need the hot air gun. I think I can just turn the soldering iron on, and then I'll take that inductor off. Why I'm doing that? It's Sunday night here. Drink of choice is a nice beer. It's 75 today here in Seattle, I think. A little bit of Stella, Belgian. Anyway, we'll take that off. We'll come right back, and then we'll plug it all together. Okay, so there we go. I've got it in there. It's not the nicest soldering job in the world, but I had to bump up because the component didn't quite stretch across the pads. I sort of had to bulk in some solder in there. But if we check across it, we can see that now I'm reading, basically the inductor should have, a 50 milliohm resistance across it. So that should work in the unit. So let's go assemble that, and we'll see what happens. Okay. So now we have the connector together. We can drop this in here, and then I should just be able to take these bulbs and plug them into here. Okay, so there we go. And so now, if everything goes to plan, when the unit boots up, we should see the light there. So let me turn this on. Oh, there we go. Look at that. So, we can see the, if you look over here, I have to be a little bit careful because this is high voltage. You'll see that we have a little red LED there indicating that everything's working correctly. Let me grab my thermocouple, and we will just carefully measure the temperature of that little unit there. So let's just put thermocouple on it. It's heating up as I would expect it to, but it's not, doesn't appear to be burning up. So I'm not sure why the bulbs went the first time. And as you see, it's slowing down on the heat. Oop, I wonder if were you able to see that? Yeah, I think you were. You can see that it's slowing down. It's, you know, it's slowly going to around 30 degrees, probably go to up to sort of, you know, anywhere around 50, I'd imagine. But the component's rated to 155 degrees C, so as long as it's not drawing too much current, that does not appear to be the case. So let's turn this off, and what we'll do is we will we'll try the, actually let's just turn it off and let's try swapping the for the new bulbs. And then what we'll do is we'll take a look at replacing the bulbs in that that little carrier there. Okay. Now these are new. I bought these from the CCFL warehouse. Oop, did turn this over. So, you know, they're 6.5 milliamp, 600 volt RMS items. So let's turn it on. We'll see how they go. And they do look a reasonable amount brighter than the other ones. So you can see them, you know, here. Okay, I'm sort of happy with that. Let's reassemble. Let's see about replacing them into this holder. So the first thing I want to do is swap out the board on the back here. So let's just take this guy out. And we will remount this guy here. Okay. So there we go. So we have our repaired board in there. Now, let me just move that screwdriver set out of the road. Okay, so we'll put that back there. Now, before I do that though, this unit here slides into the bottom there. So let's just push that out of the road here and then see how this actually goes together. So it looks like it just simply clips in. Let me grab my glasses so that I can see. Yeah, so that's all it is. It just looks like it just simply slips over that little tube assembly there. There we go. So that's the tube assembly. Let's take the new ones out. And then I think we should just be able to, if we just be careful with it. There we go. Okay. Looks like it's in there. And so we'll carefully put that aside back in the glass here, because if I bugger it up, I can always, at least we saw that this one here was working, so we can always go back to this guy. All right, now, how this went in there is because these are a backlight, this is just the touch panel, because these are a backlight, they just go into here, and so this whole assembly just basically slides into here. Okay, so there we go. Hopefully that all more or less worked. I think it might have, because the little connectors seem to be the right way around. Let me just lift that tape up again. And tape them down. Just push in. Yep, I think that's in about as far as it's going to go. There we go. So now we have the touch panel reconnected. Let's install it back in the unit. Okay. So now to get this all together and working is a little bit of the cables aren't quite long enough. So what we sort of have to do is to, basically connect this up. So this screen is supposed to go inside this bit here, but what I want to do is just to actually get this screen plugged in and working so that we can see that it actually does display. So there we go. Let's turn it on. And there we see it. Let me see if I can get across here. You can see Agilent Technologies. And so once the unit boots up, we'll see that all is up. Now the touchscreen won't work because the USB controller that runs the touchscreen isn't plugged in. But we're up and running. Okay, well, let's assemble the unit back into its case, and we'll see it all in its final look. Okay, so here we are. We've got all the unit back together again in all its original glory. I have my wireless keyboard, USB keyboard plugged in here, so let's turn it on. Let's turn this around a little bit so you get a better shot of it. All right, so we're gonna go into the setup. So we'll hit Del. Come across, we'll go to our 15-inch defaults. And we'll save those. And now the unit should boot up with all of its defaults set correctly. And it should just start. Wow. 2 meg of memory. Those were the days. I'm sure there's a way to log in using touch. I don't know what it is. I have to read the manual. I can't remember from back in the day. We can see it's detected that it's got one local frame, which is what these things are connected to. The instrument is initializing. Well, as we saw, the system clock, we'll have to go back in and set that. The touchscreen seems to be working. So that's all pretty good. So I have no idea why this they all failed on that inductor. But if I had to suspect, what I'd say is that these older tubes just got harder and harder to start, were drawing more and more current, and I think that inductor might have been too close to the 1 amp limit, and to start them it just drew too much current and blew that inductor. You know, it was the same fault by the look of it on all 3 of the cards, so replacing that inductor, as you can see, fixed the inverter, and now I have the logic analyzer up and running. Anyway, I hope you found the video interesting. If you did, give it a thumbs up, and I'll see you again for the next one.